How's it going, everyone? In this video, we're going to show how to create a box plot for a set of data. So a box plot is a plot consisting of 5 numbers, and these numbers are the minimum of a data set, the first quartile, which we'll call Q1, the median, also known as the second quartile, which we will call Q2, the third quartile, Q3, and the maximum. Now, a box plot may also show outliers, and we will do that as well once we get these 5 numbers. And just a reminder, that second quartile, it is also the median. So the data set we're working with is right here. And first thing to do is put these numbers in order so that we can find all of these 5 values that we're looking for in order from smallest to largest. So if we do that, we're going to have a 2, a 3, then a 4. We have 2 5s, right here and right here. Then we have a 6, an 8, and a 20. Good way to check that you have all the numbers is count how many. 1, 2, 3, 4, 5, 6, 7, 8. And how many do I have here? 1, 2, 3, 4, 5, 6, 7, 8. Good. And so that's our reminder that sample size equals 8. So the minimum, well, that's right in front of us. That's the 2. The maximum is the 20. And the median we can find by canceling out pairs of smallest and largest. And we end up with 2 numbers in the middle. So the median is going to be the average of those 2. Now the average of 5 and 5 is 5. So that is our median, 5. Now we need to find the first and third quartile. So I'll rewrite the numbers here just so they're not crossed out, and then we will find the quartiles that we need to find. So the first quartile, also known as the 25th percentile, we find that just as we would find the percentile. So step 1 is to find the rank. Okay, so our rank is going to be n plus 1 multiplied by p over 100, where p is our percentile that we're looking for, which is 25, and n is 8, right? We have 8 data points. So n plus 1, that's going to be 9. P over 100, that's 25 over 100. So it's going to be 9 times 0.25, which is equal to 2.25. So that's the rank that we're looking for. Okay, so the rank represents what slot the number is in, from smallest to largest. So if we write the ranks here, 1, 2, 3, 4, 5, 6, 7, 8, we're at rank 2.25. So it's going to be somewhere between the second and third rank, between data points 3 and 4. So Q1 is going to be the number at rank 2 plus 0.25, because that's decimal value right there, 0.25, 0.25 of the difference between the third data point, which is a 4, and the second data point, which is a 3. So that's going to be 3 plus 0.25 times 1, which is 3.25. That is our first quartile. The third quartile. To find that, well, that's the same as finding the 75th percentile, which is the same steps that we just did, except our rank is going to be 75 over 100 instead of 25 over 100. 8 plus 1 times 75 over 100, which is 9 times 0.75. And that comes to 6.75. So what do we have at rank 6.75? Well, there's rank 6. There's rank 7. It's going to be somewhere in between. So the 6th data point is actually a 6. So Q3 equals 6 plus 0.75 of the path to the next data point. The next data point was an 8. So the distance between 8 and 6 is 2. 8 minus 6. So that's 6 plus 0.75 times 2, which is 1.5. 6 plus 1.5 is 7.5. And that's our third quartile. So we have all of the 5 values that we need. Our minimum was equal to 2. Our first quartile was equal to 3.25 right here. Our median was equal to 5 right here. And our third quartile was 7.5 right there. And our maximum was 20. That's our maximum. So we could use these to draw a box and whisker plot, but we might not be done yet. So we have our scale. Two, 4, 6, 8, 10. 2, 4, 6, 8, 20. We can draw a line at our minimum, a line at our maximum, a box from quartile 1 to quartile 3. So if this is 2 and this is 4, 3.25, it's going to be somewhere around here. 7.5 is going to be about there. And we connect, these are called whiskers, with the box, and then a line passing through where we have our median. Okay, so that right there, this is 5, this is the location of Q3, and this is the location of Q1. But we're not done yet. We want to check for outliers. And how to do that is you look at something called your interquartile range, or IQR for short, and that's equal to Q3 minus Q1, which in our case is 7.5 minus 3.25, right? That's our Q3 minus Q1. 7.5 minus 3.25 is 4.25. And what you want to look at is the bounds that'll determine your outliers, which is going to be Q3 plus 1.5 multiplied by the IQR, and Q1 minus 1.5 times the IQR. And that value of 1.5 is just a standard number used regardless of what your data is. So for our upper bound, Q3 is 7.5 plus 1.5 multiplied by 4.25. And what that gives us, 7.5 plus 1.5 times 4.25, that gives us 13.9 approximately. So anything above 13.9 would be an outlier. Now, if we look at our data, we actually do have one value above 13.9, and that's the 20. Okay, so that 20 is an outlier, which means we have to change the box plot. If you have an outlier, you put that outlier as a dot, and the whisker extends to the next largest number, which is an 8 in our case. So we're going to go back to this box plot. We're going to erase that whisker because now the whisker only extends to an 8 right here. And the 20 gets a dot to represent that it is an outlier. Now let's look for the lower bound. Q1 minus 1.5 times the IQR. Q1 is 3.25 minus 1.5 times 4.25. So 3.25 minus 1.5 times 4.25, and that is negative 3.1 approximately. Now, we don't have any data points that are below negative 3.1. There's our data points right here. Nothing is below negative 3.1. So we don't have any lower outliers, only that one upper outlier, which is the 20. So we're done. There is our box plot right here, complete with the check for outliers as well. And that's how you create a box plot from a set of data. So I hope that helps. And if you're looking for more information on percentiles, I put a link to the lecture in the description of this video. So until next time.